Okay, good afternoon students. So we will start elasticity. Okay. So elasticity is basically, okay, in fluid mechanics we were studying about fluids or liquids, air also. In our elasticity we will be studying about solids. Okay, solids. Till the mechanics, that is one dimension, two dimension, laws of motion, rotational motion, gravitation, we were discussing about the rigid bodies, and regarding rigid bodies we were under the assumption that its dimensions will not change. Okay, so in elasticity the dimensional changes of solids we will be studying. Okay, so certain basics terminologies are important. First thing is stress. Okay, stress is force per unit area. Stress is force per unit area. So when the stress is force per unit area, is it pressure? Pressure also was what? Pressure also was force per unit area, but here we had given perpendicular. Okay, but stress is something else. Even though unit dimension wise this stress is same to pressure, but concept wise this is different. Okay, so stress is force per unit area. Okay, study in this chapter is strain. So strain is ratio of change in dimension ratio of change in dimension to original dimension. So dimension is a common word, general word. This dimension can be volume, this dimension can be area, this dimension could be length, likewise. Okay, clear, done. So here we study about three types of stress and three type of strain. Three type of stress and three type of strain. Suppose first one, longitudinal stress. So longitudinal stress is, suppose have or coil or something, okay, a rod or a coil or string or something. Okay, if we apply a force on this, suppose if this area of cross section is A. Okay, the best example is, suppose if we have something like this, and if we are connected a mass on this, what will happen? mg will be acting on this. Obviously that length will be elongated a little. Okay, so longitudinal stress or linear stress is nothing but linear stress, or longitudinal stress is nothing but force divided by this cross sectional area. Correct or what? Right. When we do this, what will happen? This an elongation in the length. If this is the original length L, this is the changed length delta L, then we can say that linear strain is equal to what? Change in length divided by original length. Clear? Done? Hippo, as usual, this force is nothing but Newton, and this is going to be meter square. That is just like the SI unit of pressure. Okay, we don't say Pascal. Okay, we don't say Pascal because Pascal unit is exclusively for pressure. So even though this is a SI unit, Newton per meter square, it is coming correctly, but we don't use Pascal because this is not pressure. Clear or what? Done? Fine. So this is about longitudinal stress and longitudinal strain. Okay, clear? Understood? Now the same thing, okay, same thing can be done using compression also. Suppose, okay, see, if the same thing, okay, we applied force in the opposite direction. What happened here? Okay, this much length is decreased. So what is again here linear strain? Linear strain is delta L by L. Delta L by L. Clear or what? Okay. When I say about this stress, I said force divided by area. Force divided by area. Whether this force is same as this force, the force I mentioned, what? Direction is what? What is the direction? Not about this one. I am asking, this one is fine. Okay, we have compressed this one. We got delta L by L. Coming back to same thing. I applied a force F. Linear stress is equal to force by area I have written. Now suppose if I name, say a name for this force, not technical name, any Tamil name, Raju. This force is, every name Raju. Okay, not Rajan. Okay, so the force name is Raju. So this force is also Raju. No. Yes. What? Same. Okay. See now, children. Suppose I am standing here. Okay. Someone is pushing me. Okay, so someone is pushed to that side. So immediately I do not know that he is going to pull me. Not pushing, pulling. So he is going to pull me. I do not know. So immediately he pulled. I just went like this. After that, what I don't want to go further. So I will be applying same amount of force. Same amount of force that guy is pulling me. Okay. Same amount of force that guy is pulling me. I am standing like this. Immediately one more person joined there and they started again pulling me. So I went to further distance, but I increased my force and I am standing like this. Now again they are increasing the force. Again I went to so much and again I am increased the force and I am standing here. External force. External force increasing, change in dimension. Restoring force. I have developed a force in this direction so that I don't want to undergo further. They increased the external force. I increased my restoring force, but still again I have went, because I cannot detect that this much force they are going to do, right? So 1 Newton external force, displacement, 1 Newton restoring force. 2 Newton external force, 2 meter displacement. Again F restoring is also 2 meter. 3 Newton external force, displacement is again 3 meter. Again I increased my restoring force. Understood or what? So stress is actually, technically speaking, this stress is actually what? This is F restoring. Stress is actually F restoring. Nama solule so much stress. We say no, so much stress. Why so much stress? Because we are loaded with the work. So this is experiencing stress actually. External, this is external force means we need not name it as stress, simply force R. Correct or what? Done. Understood? So restoring force will be acting. So this molecular action, they don't want to admit a change. Okay, any change that happens, this will try to reject. So while trying to reject, it will experience a force from inside. To certain level, the applied force and restoring force are equal, but not always. So that all things we will discuss. Clear or what? So longitudinal stress, longitudinal strain. Applying for expansion, applying for compression. Strain is nothing but changing length by original length. So the unit of this one is Newton per meter square. The dimensional formula is mLt raised to -2 divided by L square. What we will be getting? mL raised to -1 T raised to -2. So this is about stress. What is the unit of strain? This is actually ratio. This is also length, this is also length. Change in length by original length. Meter by meter cancel. No dimensional formula, no unit. Next one is shear stress and shear strain. Suppose if you keep something like this and you are applying a force in the tangential direction, this force is tangential to this plane. Okay, so what will happen if you take a thick book? If you apply force tangentially, what will happen? It will slide. No, it will. Correct. So this is a thick book. I am applying force in the tangential direction. See, this is displacing. This is what is shear stress and shear strain. So what will happen? This will displace like this. Suppose if this length is L, how much is displaced? Suppose if we name this as X, okay, then shear stress is equal to what? F tangential divided by area. Okay, F tangential divided by area. What about shear strain? Shear strain is equal to this displacement X divided by this height L, length. Okay, If we put a theta there, if we put a theta here, then we can say tan theta is equal to x by L. What is this? This is also shear strain. This is also shear strain. When theta is very small, we could say theta is equal to x by L. This is also what? Shear strain. Clear? Any confusion, children? Old Amitabh Bachchan movie is there, Shahinshah. When I was small, Shahinshah, Amitabh Bachchan's movie. Okay, now this one, see, done. See, children, so here also stress is equal to force divided by area. All stresses are same unit, same dimension. Okay, pakka? Done. Now volumetric stress, then volumetric strain. Volumetric stress, volumetric strain. So here this is nothing but, suppose if we put a body inside a fluid, okay, suppose if this was the body, what will happen? What this fluid will do? This will apply force in normal to the area of this body. Correct? Small change in dimension will happen. Okay, but what we are showing here, even this also, these are all very small change in dimensions. Okay, very small change in dimensions, but we are showing this as very big one. Okay, so if a force is, what will happen? Suppose if its size is reduced like this, okay, so its volume is changed. Correct or what? Now this volumetric stress, okay, volumetric stress is equal to, this is actually force divided by area, but here this volumetric stress is pressure. This is actually pressure. Volumetric stress is pressure. So volumetric strain we can say delta V divided by V. Since this volume will be always decrease, we can say negative. Okay, in the case of volumetric stress and volumetric strain, this is always going to decrease. So we can put minus V, minus delta V by V. Is it clear? These are the three types of stress, three types of strain. Okay, makle? Done? Okay. Shall I erase this? Now suppose if we consider this linear stress, F restoring divided by A. So this is proportional to delta L by L. Okay, just like if we increase the stress, the strain also will increase. If we increase the stress, the change in dimension divided by original dimension also will increase. Correct or what? So suppose when we do this, is it possible to equate these two? No, some other factors are also coming. Suppose if I take steel, F by A is not equal to delta L by L. Some difference is there. Okay, so we found how much is the difference. Say for example, Y is equal to something, we noted down. We took copper, we applied stress, we observed strain, we just checked whether stress is equal to strain or not. No, some difference is there. So this is steel. Again we have noted some difference is there, that also we noted. So likewise we have taken other copper, steel, iron, all these things we have seen. We understood that this will be equal if we add something based on the property of the material into the equation. Clear? Steel it will be one value, for copper that will be another value, for iron that is going to be another value. That is called modulus of elasticity. When a new baby is born, we will be putting Raju, no? Okay, so those people used to speak English, Latin, Spain and all. So they put that one. If we could have found out, no, if we were there, we would have put what? Modulus of Raju. Okay, elasticity, we would have put what name? Salem, we would have put the names. Okay, but they found, so this is the names. So what happened? They equated this F by A is equal to what? Modulus of elasticity. Y is equal to F by A is equal to Y into delta L by L. This is called modulus of elasticity. So same thing is done for shear also. Same thing is done for shear also. F by A is equal to what? X by L. X by L. Here also there was something. Its name is also what? Modulus of elasticity. Okay. Same way here. F by A is equal to minus delta V by V. Here also we have put another one. This is also what? Modulus of elasticity. Correct? Okay, so this is for linear, this is for shear, this is for bulk or volumetric. Okay, for volumetric we say bulk also. So in the class, if everyone has the name Arun, we won't be able to recognize. Correct or what? So this modulus of elasticity was named as Young's modulus because this was found by Young's modulus. Correct? This is called shear modulus. Doesn't mean that the scientist's name is shear. Okay, this is called bulk modulus. Okay, perfect. Able to understand? Okay, most of the discussion, okay, most of the discussion is on this longitudinal stress, longitudinal strain and all. Okay, some discussions will come in shear stress, bulk modulus. We will discuss that also. Most of the discussion, some time will be spent for this one. Okay. Alright children, so here F by A is equal to Y into delta L by L. Young's modulus is equal to F by A divided by delta L by L. Delta L by L. So if I increase this force, Young's modulus will increase. Increase agada. Increase agada. What? Makkale. Irukra makkale. Endringa. Inga paru. Inga paru. Inga. So Y is equal to F by A by delta L by L. So if I increase this force, this Y will increase or what? No. It will not increase. This is the property of the material. Property of the material. Clear? Done. So this is constant always. Okay? Constant. Okay. Now we can write Y is equal to FL divided by delta L into A. Okay? Young's modulus is equal to FL by delta L into A. Okay, so this is actually based on when we could say stress is proportional to strain. So based on this concept only, this Young's modulus we are seeing. Clear? Okay, fine. Now let us see. You put the heading stress strain graph. Stress strain graph. Okay, done. Okay. Here we mark stress and here we mark strain. Okay. Stress is proportional to strain. When stress is proportional to strain, its shape will be circular, no? Then Ibia. Linear. Okay, fine. So stress is proportional to strain. Okay, cell angle that time you should help me. Okay, then I won't be able to. So this is going to be straight line. Stress is proportional to strain. This is going to be straight line. So suppose if this is origin, okay, till some point stress and strain will be proportional linearly. Okay, Hooke's law. When you increase the force, okay, it will the dimension will be increased. Again, if we increase the force, the dimension will increase. Everything will be pakka. So this Young's modulus, okay, all these things will come here. Okay, so stress is proportional to strain. This is called what? Hooke's law. Okay, Hooke's law. Okay, stress is proportional to strain, and till this point, okay, stress is proportional to strain. This is, we call them proportionality limit. Okay, we will extract some information from this. Suppose if I put a theta here. If I take tan theta, what info I will be getting from that? What is that? Slope. So when we take slope, what I will be getting? Stress by strain is what? Young's modulus. So slope of stress strain graph till the proportionality limit. If we take slope of stress strain graph, the information we will be getting is what? Young's modulus. We are doing this for linear or longitudinal stress and strain. Clear? So, oru payyan, he is studying well, okay, so he is okay further, no problem. So some people started teasing. Some people started teasing. So throughout the day he will be teased. So teasing allam padumbodhu someone will motivate him. So friend will say, you should be very strong, come on, you can do, adu pandravanga po sollunga, idella sollumbodhu he will be feeling angry, but again he will come back to normal. Okay, so ini vandu nama paaka poradhu andha aaluda kadha dhaan. Okay, andha payyan per enna? Vikram. Okay, Vikram per bodala Vikram. So what happens is Vikram, when again too much, so inga varaikkum when someone is teasing, he is very cool. After that what happens is when after that again if someone is teasing, he starts losing his that cool attitude. So what happens is again, okay, till this point, okay, stress is not proportional to strain. கோபம் வருது ஓட்றதோட அளவுக்கு தகுந்த மாதிரி அல்ல. How much others are teasing, the angry level is not based on that level, because already someone has done lot of kindle. Understood or what? Now this time stress is not proportional to strain. Stress is not proportional to strain. This is proportionality limit. So till a stage what happens after this proportionality limit? Till a stage he will be able to come back to normalcy. So the thing here it is, based on the stress, the dimension will change, but dimension is not based on the proportionality. Stress is not proportional to strain now, but again it will come back to original dimension. Understood or what? Okay, inge ipdi konjam otranga, okay, konjam kovam varudhu, innum konjam otranga, innum konjam kovam varudhu, again it will come back to normal. Inga na based on the teasing, the angry level is more. That is here the change in dimension is not proportional. Change in dimension is little bit more. Okay, see, this is what is strain. This is bending a little. So for small stress, more strain. Konjam otal naraya kobam andha madri. Clear? So we could say this point as elastic limit. We call this as elastic limit. Suppose this is O, this is A, this is B. We can say OA is proportionality limit and AB is elastic limit. Elastic limit is this what? B. Elastic limit is B, but between A and B it can come back to original dimension. Normal level ku vandidu. Inidhaan okay, done. இனி என்ன நடக்க போகுது? ஓட்டும் போது he will go mad. அப்புறம் நார்மல் லெவலுக்கு திரும்பி வரவே முடியாது. Okay, beyond some horrible experience, people cannot come back to normal thinking இல்லையா? No, mind pati. Okay, so same way now what happens is after B, if we increase the stress, this strain, no, this strain will happen, it cannot come back to the original dimension. Beyond this elastic point, beyond this elastic limit, if we apply stress and if there will be strain, it will not come back to original dimension. Okay, original dimension. So appadi poi here a maximum level will be there. So at this will be the maximum stress possible, but after that, even if we reduce the stress also, there will be one point. This is called the breaking point. Okay, this is the break. So 0, A, B, this is C, this is D. So C is the maximum stress we can apply. Okay. So keep till this, what will happen? It will be break point. Okay, children, right? So without breaking, how much we can elongate something? Adukku enna pair? Malleability, ductility. Malleability is flattening. That is also fine. Adu inge fit agum. That is also true. Ductility means we can draw into fine wires. So till this, what will happen? It will come back to original dimension. So if we see this, if this length is more, we can say the material ductile. Okay, so if BD is more, we can say this is ductile. Malleable also correct. Okay, that will bear. Okay, if this BD is less, we call them brittle. Done? Clear? Understood? Right. Shall I erase this? Okay, see children, elasticity okay, suppose if we are trying to change the dimension of something, one material doesn't allow to change its dimension, another material it is easy to change its dimension. Which is more elastic? Which is ready to change? This concept we got from some material which we are using in our day-to-day life. Okay, actual meaning is different. Elastic means it will not change its dimension that easily. Correct or what? So in the notion is there, because elastic, patak, plastic, rubber band, katak. So we think that okay, then this is going to be what? When they will think that this time we will make the exam easy, and if they put this question, we all will do that mistake. Children, okay, if you read Ncert, we will not say that. Okay, so elasticity is change the dimension. Okay, and such materials are called what? Elastic material are like that. such, okay, reluctance to change the dimension, very difficult to change. I could say that steel is more elastic than copper. Steel is more elastic than copper. Steel is more elastic than rubber. Steel is more elastic than rubber. Clear or what? Okay. Now suppose you have taken plastic, you are trying to change its shape. Just like atta you will be making, no atta, not you, mothers. Okay, have you done this once in your life? எப்போவாவது இதெல்லாம் பண்ணிட்டு சப்பாத்தி எல்லாம் பண்ணிருக்கீங்களோ? சப்பாத்தி ஓகே, ஸோ அந்த இது இருக்குல்ல ஆட்டா எப்படி இருக்கும்? See, so இப்படி இது இங்க இருக்குது, பிடிச்சுக்கோங்க. ஓகே, then plastic, you are trying to do the same. எப்படி பண்ணணும்? Just like you have done with atta, you want to do with the plastic also. Is it possible? No. Okay, bala plastic. Okay, now which is more plastic? Plastic. Which is more plastic? Just like the previous case, you wanted to give the reverse engineering. Correct. Okay, this thing, no, atta, this is more plastic. Okay, so the materials which is ready to change, and it will not come back to original dimension. Once if we change, it will not come back to the original dimension. That is what is plastic. Plasticity. Okay, done. Okay, what is plasticity? The property of the material, the property of the material okay, the property of the material by virtue of which it changes the shape easily. Okay, changes the shape easily and won't come back to original shape by its own. Okay, so one example is clay, mud. Correct, we like to play with the clay, no, using clay, different shapes. Okay, so children like to play with the mud, same thing. Okay, so elasticity, plasticity, example clay and mud. Okay, so these properties are important. Okay, done. Okay, children. Okay, so that is the intro about the chapter. Remaining things is, after doing some problems, we will see those points of the chapter and we will address that also.